All right, I'm going to tell you a little story about this girl. Her name is Christina Santhouse. And Christina is this little girl. We got to draw a picture of her. We're going to put a flower in her hair because that's who she is. She's wearing a dress. Here she is. And Christina's 8 years old. But she has a problem. And it's a pretty serious problem. Because she suffers from seizures. In fact, she suffers from about 150 seizures a day. Yikes. So, this is back in, what year was this? 1998. 1996. This is in 1996. So, what do you do when somebody has a problem? Well, you give them drugs, right? So, the doctors gave her parents drugs to make her take, and she took the drugs, and they didn't help too much. So they gave her more drugs. That's a drug bottle. And pretty soon, she was just taking a ton of drugs, and they weren't helping a whole lot. And in fact, they just kind of doped her up a bunch, and she wasn't functioning very well at that point. So something had to be done, right? What do you think they came up with for a solution for this little girl who's 8 years old, who's having 150 seizures a day? What do you think they're going to do? Well, as it turns out, they did something pretty radical. I have a brain over here. Okay. This is what they did. I'm going to go ahead and demonstrate the surgery. Brain surgery is pretty delicate type of operation. So let me show you exactly what they did. So pay close attention. It's a really detailed process. This is what they did. They threw this part away. With only half her brain. They took out half her brain. So the question is, why in the world would they do that? And to answer the question, we have to kind of talk about brains for a second. So bear with us here. We have our nice bloop, 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 bloop. Here we go. Here's our brain. An extra squiggly bit in the back. We have this loopy bit here in the middle. Some dangly parts. And then we have this part coming down. That goes into our spinal cord. Okay, so that may be not the greatest drawing ever, but that's okay. And let's talk about a few of these parts. This main part is called the cerebrum. And the front of it is called the prefrontal cortex. We're not even going to worry about the back part. This part's called the brainstem. And then a couple of these little lumpy bits in the middle. There's a bunch of them, but we're just going to focus on two for right now. This one is the hippocampus. And over here, this is going to the amygdala. Okay. And the amygdala is your center for things like emotions. It also closely controls like hormones and stuff like that. Your hippocampus, that does things like memory and helps with physical space. Your brainstem, the brainstem does your very, very core type things. When people are brain dead, their brainstem still continues to function. So this is things like eating, or not even eating, just swallowing, breathing. It helps run your basic functions like not really your heartbeat, but your heart rate, and your all the neurons that are involved in like digestion and stuff like that run through the brainstem. The stuff you don't think about. And then finally, this is the thinking section up here. The cerebrum does all the basic thinking, and in the cerebrum is this prefrontal cortex, and that's where your decisions are made. So this is important because of how you develop. And it's really key to note here that brain parts grow at different rates. So, let's take a look at some of these. One of the first ones to develop is the brainstem. This is early. When can you breathe? As soon as you're popped out. So this is pretty much developed by the time you're just absolutely tiny. These parts of your brain, remember, these control things like emotions and memory. Do you have emotions when you're a little tiny thing? Oh, you bet you do. These, however, usually are fully developed at about the age of 9. When you're 9 years old, those are usually fully developed. The other section, this is remember the thinking and the decision-making section. These are done at about the age of 25. Up until about age 25, these are still developing. This is why college students make such poor decisions, almost as much as high schoolers. All right, so a little bit more about science, about the brain. Sorry, I'm grabbing a new sheet here. Nice and clean. Is you need to know what a neuron is. And we don't have to go into a ton of detail on this, but of note, a neuron is a cell in your brain that conveys information. And the way it does that is it has a long, thin section that sends an electrical signal down. And at the end of that, it connects to another neuron. So these all hook up in a series, and they can connect to each other, and they can make really big, long paths, but they can also branch out. They're basically wires. So let's think of another analogy here with all these connections. Let's think of these towns. Okay, so I drew these dots. Think of these dots as, actually, I'm going to spread them out. Okay, I'm going to draw another little collection of dots here. I'll try and make them spread out though, so they're a little bit bigger. Here's one, here's one, here's one. Okay, so let's say there's these 6 towns here, and between each town is a little path. Boop, boop, boop. We're going to draw all the options. Boop, 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 boop. I'm missing a couple. Okay, that's pretty good. Okay, so here's all the paths between these towns. And as long as each path is being used, it's still hanging around. But then eventually, one day, forgot that one. There's, let's say, over here, there's a bunch of gold that's discovered. And over here, they have a bunch of salt. And then here in the middle is this oasis, so they can travel between the towns. So instead of traveling among all these towns, the people decide, oh, hey, I really want to get over here so we can trade back and forth, and the people over here want to trade back. So they all start walking across this path here. This is their new favorite path. This gets all the traffic. Everyone's going down this path. And when you have a whole bunch of people going down the path, it becomes a road, right? It becomes nice and wide. And then what happens to these paths? On those paths, if there's nobody walking along on a path, eventually it becomes overgrown, right? So these paths eventually just disappear. Head is what erase. And the only path that's left is the one that's being used. And this is exactly what happens in your brain. The neurons that aren't being used actually begin to die. They begin to get pruned back and they get removed. This process begins when you're about 2 years old. Pruning begins. And your max pruning rate is when you're about 16 years old. So the point here is what? Well, it's when you're 16, the way you act as a 16-year-old has long-lasting implications as to what type of person you become. So let's go back to Christina. Remember that little girl? Flower in her hair. 8 years old. When she gets half her brain removed, she gets paralyzed on one side. Burp. However, with a short period of time, within a year or so, she recovers from the paralysis. Her brain, that single half of the brain, begins to make up all of those motor functions. It begins to make up all of the other functions that side of the brain was doing. It actually grew new connections. And she went on, made her head tiny. She's super tall now. Her face is weird now. See, she's happy. She went on to get a master's degree with even half of her brain. So, if Christina can get a master's degree with half a brain, think of all the things you can do with all of your brain right now.